Good day, grade 11th. Today we are going to look at application of our analytical geometry to quadrilaterals. So what we are going to be doing here is working, most quadrilaterals are four-sided shapes. So we are going to look at like trying to prove that a quadrilateral is maybe a parallelogram or a rectangle or a square or a rhombus, or even a trapezium, or trying to show or prove that it is a kite. So all the properties. So the first thing that I would ask you to do is just to copy that table on page 76 and 77 into your exercise books, because it will help you. You need to know the properties before you can work with this. The properties are the same as the ones that you did in grade 10. That's why I'm not going over them. Okay, so the ones that we will need, I'm going to just do a quick recap on them. Okay, so the first thing that maybe would be asked is, let's say they're asking you to prove parallelogram. We know parallelogram has opposite sides that are parallel to each other. So to prove that sides are parallel, it means that you have to show that they have the same gradient. So you calculate the gradient of this side and that side, and then if they are the same, and then also top and bottom, if they are the same, then it is a parallelogram. So that's what we are going to use. These are the proofs that we will use. Okay, and then for the rectangle, square and rhombus, opposite sides that are equal, we use the distance formula to find the length of the sides. And then also diagonals bisect each other, so we must show that they have the same midpoint. It is very important to remember this part as well. Now, sometimes you're asked to distinguish between the two. Must you remember that a parallelogram is a slanted rectangle. So it means it will have almost all the properties of a rectangle. The side is equal to that, but longer than the other two sides that are also equal. And then the only difference between a rectangle and a parallelogram is that the diagonals, they still bisect each other, but the diagonals are not equal. This one is longer than that one. So if you are asked to distinguish, then you must show that this diagonal is longer than that one, whereas in a rectangle, this diagonal is equal to that one. So that's how you would distinguish between the two. Distinguishing between a square and a rectangle. Okay, again, both of them are parallelograms, but now you can either show that all sides of a square are equal, so that will be okay. And then also the diagonals of a square meet at 90 degrees, while the diagonals of a diagonals of a rectangle don't meet at 90 degrees. They are not perpendicular to each other. Now, distinguishing between a square and a rhombus. Now, the square and a rhombus, they've got all sides equal. Then they've got diagonals that are bisecting each other, and they meet at 90 degrees, so they are perpendicular. Now, the only difference between a square and a rhombus is that the diagonals of a rhombus are not equal, so this one is longer than that one, while in a square the diagonals are equal. So you have to know all these differences if you are asked to distinguish between the shapes. And then for the kite, the longer diagonal bisects the shorter diagonal, so that means E is going to be the midpoint of DE and DB, and then DE is going to be equal to EB. So if you can show that, if they say this is a kite, or maybe you're asked to find out if this is a kite, then you have your longer diagonal and your shorter diagonal. If you can find that the point E is indeed the midpoint of BE, then it means that this is a kite. And then also two pairs of equal adjacent sides. And then to prove that, you can use the distance formula. So basically that's what we are going to do in this exercise. So let's look at just one example. I took it from exercise 8. You can look at the example that comes before exercise 8. Okay, I did number 5. We are given that ABC is a rhombus. So as soon as the question says this, input all the properties that you know on the question. So this was given to me in blue. So now I've inputted the I input the the properties that I know of a rhombus using my red pen. Okay, so I know that all sides are equal, so that's what I did. This side is parallel to that one, this one is parallel to that one, and then only one diagonal was there, so I put the second one, and then I put that they meet at 90 degrees. It's important that you do that so that when you carry on with the questions, the diagram will assist you, because now you have everything that you need in there. Okay, first question says calculate the equation of find the equation of AC. As you can see, AC has got 2 coordinates, so we are lucky we can find the gradient of AC and then use the equation y minus y1 to find the equation. That one is straightforward. Sometimes instead of giving you the 2 coordinates, they would have given you here maybe the inclination over there, inclination of AC. So remember, inclination of AC will also provide you with the gradient, so don't forget that. Okay, equation of BD. Now BD is like this. So now you see, if I didn't put this 90 degrees, then I would tend to forget that they are perpendicular to each other. And then as you can see, BD, there are no coordinates there. There's no coordinate there and there, so we can't find the gradient by calculation. So the diagonals are perpendicular, so BD, the gradient of BD is going to be the negative reciprocal of AC. So the gradient of BD is then going to be negative 2/3, which is what I've written there. Okay, now we are asked to find the equation. So now if you check again there, we don't have a coordinate that we can see, but because we know that the midpoint of AC is the same as the midpoint of BD, we can calculate this point here, the midpoint. So if you calculate the midpoint, then it's a coordinate that lies on BD. So that's what I did. I calculated the midpoint and I found it to be 1, 1. So the coordinate at the point at the midpoint there is 1, 1. Then now I can use that because it's a coordinate that lies on BD. And then I calculated the equation. It came out as negative 2/3x plus 5/3. Okay, then C, it says determine, you are given that D is 6y, determine the value of y, and then the coordinate of B. Okay, so to find the coordinate, the y coordinate here, we use the equation that we have calculated of BD, and then you substitute x equals to 6. So y comes out as negative 7/3, and then you can then rewrite the coordinate like that. And then to find the coordinate of D, this one, then we work backwards using D and the midpoint that you have calculated. So that's what I did. The midpoint, we calculated it as 1, 1. And then the midpoint, it's a midpoint of BD. So it's going to be x plus 6/2, and then y plus negative 7/3 over 2. And then you work backwards. So that's what I did, which is like similar to what we did earlier on. So then you equate the x's together, then you equate the y's together, and you solve for x and y. And then the coordinate becomes -4 and -4/13/3. Please leave it like that. Don't write it as a decimal. Okay, so that is what it is. I hope it is clear. So again, these are types of questions that you can get in a test. As you can see, it is making now use of everything that we have done Please do exercise 8, number 2, and number 6. Thank you.